The personal computer's history is a tapestry of innovation, competition, and occasional missteps that transformed computing from room-sized behemoths, yeah, they really did used to be room-sized, into devices that fit in our pockets. From the rudimentary 8-bit systems of the 1970s to the mobile and AI-enabled devices of today, this journey reflects humanity's relentless pursuit of technological advancement. Key milestones include the rise of microprocessors, the battle between operating systems, and the democratization of computing power, which in itself is an important concept. Alongside these triumphs lie the pitfalls of failed standards, incompatible architectures, and fleeting market leaders, each shaping the trajectory of modern computing. The dawn of personal computing, 1940s to 1970s. So, the foundation of modern computing began with mechanical and electromechanical devices in the mid-20th century. However, the invention of the transistor in 1947 by Bell Labs marked a seismic shift. These semiconductor devices replaced bulky vacuum tubes, or valves as we used to call them in the UK, enabling smaller, faster, and more reliable machines. Now bear in mind that modern computing is largely based upon digital logic systems using binary data. The vacuum tube was used as a simple switch, providing the binary 1 or 0 condition, on or off. This was followed by the solid-state transistor, which could be combined into more complex integrated circuit packages. Even later, transistors formed the building blocks of microprocessors and then SoCs, systems on a chip, which can contain the equivalent of billions of transistors in contemporary devices like smartphones and laptops. By the 1960s, integrated circuits paved the way for the first mini-computers, like Digital Equipment Corporation's PDP-8. These machines, although still big, hinted at the potential for individual access to computing power. The birth of the personal computer. In 1971, the Kenback-1 emerged as the first device recognized by the Computer History Museum as a quote-unquote personal computer. Designed by John Blankenbaker, it lacked a microprocessor and relied on small-scale integrated circuits. Despite its limitations, 256 bytes of memory and no expandability, the Kenback-1 symbolized the nascent idea of individualized computing, which was not a thing until then. Meanwhile, IBM's SCAMP prototype demonstrated early portability, earning recognition as the world's first personal computer by PC Magazine for its ability to run APL, a then advanced programming language. The Altair 8800 in 1975 catalyzed the microcomputer revolution. This is generally the one that people think of as the first personal computer. Sold as a $400 kit, which was a lot of money in 1975. It featured an Intel 8080 processor and an open architecture that invited hobbyist experimentation. However, its usability challenges, no keyboard, display, or built-in software, highlighted the gap between hardware potential and user accessibility. This void would soon be filled by visionary startups. The rise of consumer PCs. The Apple II. Steve Wozniak's masterpiece combined color graphics, expandability, and a sleek design. Its success surged with VisiCalc in 1979, the first spreadsheet software, which transformed PCs into potential business tools. The Commodore PET. An integrated monitor and cassette drive made it a classroom staple, although its chiclet keyboard drew criticism in some areas. The TRS-80, affectionately known as the Trash 80, was Radio Shack's entry, and it offered affordability, becoming a hit despite limited graphics. I actually had a later version of one of Radio Shack's computers, the Color Computer 3, and it was pretty slick. It was like similar to a Commodore 64 in style. It was the one-piece keyboard type thing, and it had built-in BASIC, and I actually would program a little bit in BASIC on it. It was great. These systems popularized 8-bit architectures, but faced constraints like 64 KB memory ceilings and reliance on cassette tapes for storage. Yeah, cassette tapes weren't the most reliable thing in the world for storing programs and retrieving them. The GUI revolution and IBM's dominance. In 1981, IBM entered the market with the IBM PC, powered by Microsoft's MS-DOS. Its open architecture spurred a clone ecosystem, but IBM's proprietary PS2 bus, introduced in 1987, aimed to stifle competition, a strategy that backfired as clones adopted cheaper, compatible standards. Meanwhile, Apple's Macintosh in 1984, hey, remember the commercial? Revolutionized interfaces with its GUI, graphical user interface. Although its high price limited initial adoption, Apple was not the first to introduce the concept of the GUI, or graphical user interface. That was Xerox, but Apple did make it popular. Microsoft responded with Windows 1.0 in 1985, beginning a decades-long OS rivalry. The modern era, miniaturization and mobility. The 1990s saw Intel's Pentium processors and AMD's Athlon 64, which brought 64-bit computing to consumers, enabling complex applications and multitasking. Storage evolved from floppy disks to hard drives, CDs, and SSDs, while Ethernet and Wi-Fi standardized connectivity. The mobile revolution. Touch, ARM, and Microsoft's reckoning. The iPhone in 2007 and iPad in 2010 redefined personal computing by prioritizing touch interfaces, app ecosystems, and energy-efficient ARM-based processors. Apple's vertical integration, combining hardware like the A and M series chips with software, iOS and macOS, demonstrated ARM's potential beyond mobile devices. The M1 chip in 2020 marked a turning point, delivering desktop-class performance in a laptop while maintaining smartphone-like power efficiency. This success pressured traditional x86 ecosystems, particularly Microsoft Windows platform, to adapt or possibly fall behind in the consumer market. Microsoft's early mobile efforts faltered with Windows RT in 2012, an ARM-based OS incompatible with legacy x86 software. Despite Surface hardware innovations, the RT's 0.2% market share by 2013 underscored its failure to balance compatibility and performance. The Windows Phone era, 2012 to 2018, fared no better, with Microsoft's closed ecosystem unable to compete against Android and iOS app dominance. By 2016, CEO Satya Nadella shifted focus to a cloud-first strategy, prioritizing cross-platform services like Office and Azure over proprietary mobile OS development. This retreat marked a long-term recalibration, recognizing ARM's architectural advantages, energy efficiency, and thermal headroom for AI workloads. Microsoft reignited its Windows on ARM initiative in 2017. Partnered with Qualcomm, they launched Always Connected PCs, featuring Snapdragon chips, promised LTE connectivity and 20-hour battery life. Early devices like the Surface Pro X in 2019 struggled again with x86 emulation overheads, but laid the groundwork for a rebuilt ecosystem. The ARM ecosystem reboot. Apple's M-series success accelerated Microsoft's ARM investments. Windows 11 reduced x86 app performance penalties by 30% in 2021 to 8%, while native ARM apps like Spotify saw significant launch time improvements. The AI inflection point. ARM's scalability proved pivotal for on-device AI. Microsoft's Copilot Plus PC initiative in late 2024 mandated ARM-based NPUs capable of 40-plus TOPS, or trillion operations per second, enabling real-time translation, photo-video synthesis, and context-aware OS features. Qualcomm's Snapdragon X Elite, 45 TOPS, and NVIDIA's ARM-based CPU-GPU hybrids position Windows as a leader in AI-driven mobility. The personal computer's history is marked by the interplay between hardware innovation and software ambition. I've been fortunate enough myself to actually live through a good part of this, seeing us go from, computers being something out of science fiction to now walking around with marbles in your pocket or on your wrist. Early pitfalls like the Kenback One's rigidity or the Altair's usability gaps emphasize the importance of balancing technical prowess with user needs. The rise and fall of giants like Commodore and IBM illustrate the potential perils of proprietary lock-in, while open ecosystems like Windows clones and Linux demonstrate the power of collaboration. As computing evolves into wearable and probably quantum realms, these lessons remain. Adaptability, accessibility, and interoperability will surely define the next chapter of personal technology. Hope you folks enjoyed that. Take care. Catch you next time.